Good evening, dear students. So today we are going to discuss the topic amines. Okay, so what are amines? Yes, what are amines? What do you mean by amines? So already in our ACE classes we have discussed, right? What are amines? Can anybody tell me what are amines? Yes. How do you represent amines? Yes. How do you represent amines? What are amines? Right? So amines are the organic compounds, right? They are the organic compound which consists of nitrogen, right? It is an organic compound which consists of nitrogen atom, right? So how do you represent this amines? How do you represent this amine as RNH2? Yes, very good, Sri Varuni. Okay, so we represent the amine as RNH2. Okay, so this is a general representation of amines. Okay, so amines are the organic compound which consist of nitrogen atom. Okay, so uh, I hope you have gone through the synopsis. Okay, uh, so already we have discussed in detail about the amines. Okay, so what all things are there in the amines chapter? Firstly, the physical properties, chemical properties, right? Then the preparation of amines. Then the important that is a diazonium salts, right? Preparation of diazonium salts, physical properties, chemical properties, nature of amines, right? So these all things are included in the chapter. So based on that, so let us see few questions. Okay. So these are the questions, okay, from the chapter amines. So first question is amines behave as. So how does amine behave as? A protic acid, B, neutral compound, C, Lewis acid, and D, Lewis base. Yes, how does this amines behave as? So amines, the general representation of amine, just now I told RNH2. So how do these amines behave as? Yes. What do you mean by aprotic acid? Okay. So these are the four options. So you have to understand, okay, what is the meaning of each word? What do you mean by aprotic acid? Yes, anybody? What do you mean by aprotic acid? How does amines behave as? Aprotic means what? Aprotic. Aprotic means what? It is having, it is what? It is lacking a proton. Okay, aprotic acid means what? The solvent that does not contain an acidic protein. Okay, so because of that, it is unable to act as a proton donor in the hydrogen bonding. Okay, so this is the meaning of the aprotic. Okay, so they are what they are. They can be your polar or non-polar solvent. Okay, protic acids. Okay, they can be the solvents. They can be polar or non-polar. Okay, but they do not consist of the. They lack in that acidic proton. Okay, so amines do they behave as aprotic acid? Neutral means neither acid nor base. Okay, neutral compound. C, Lewis acid. What do you mean by Lewis acid now? What do you mean by Lewis acid? So you need to know the meaning first. What do you mean by Lewis acid? Lewis acids are those which accepts a pair of proton, right? It accepts a pair of proton, right? So what they do, they accept a pair of electrons here, right? Lewis acid accepts pair of electrons. Then what are Lewis base? Lewis base, what does Lewis base do? It donates, okay, it donates pair of electrons. Okay, so so now after seeing the structure of this your amines, what do you say? Okay, accept protons. Okay, donate electrons. Okay, so which is the answer now? Amines behave as, how do they behave as? So on the nitrogen, when we see the structure of amines, So nitrogen consists of lone pair of electrons. Okay, so means what? It is the amines. Okay, they are capable of donating a pair of electrons, right? They can donate the pair of electrons. So donating a pair of electron means they act as a Lewis base. Okay, yes. Sri Varuni has answered it correct. And one more answer I have got here. Karima. Okay, very good. They have answered it as D. Very good. Okay. So amines, they behave as what? They behave as a Lewis base. Why? Because they donate pair of electrons. Okay. Because nitrogen has lone pair of electrons, so they are able to donate the pair of electrons. So yes, option number D is the answer. Let us go for the next one. Arrange the following in the increasing order of their basic strength. You have to, so there are few compounds given here. Okay, you have to arrange them in the increasing order of their basic strength. So which are the compounds which are given here? So first is methylamine. Okay, the first compound is methylamine, CH3NH2. Then dimethylamine. Okay, then is dimethylamine. Then is trimethylamine, CH3 thrice N, and ammonia. Okay, so these are the four compounds. So you have to arrange in their increasing order. Yes, how, what is the answer? Methylamine, dimethylamine, trimethylamine, and ammonia. So arrange in their increasing order of their basic strength. Yes, what is the answer, students? Try to answer. Okay, Sri Varuni has answered it as A. Others? So when we discuss about the basic strength, okay, Karima has answered as C. Okay, let us see. So here when we discuss about the compounds, okay, based on their basic strength, ammonia, okay, ammonia is the weakest. Ammonia is the weakest base. Okay, this is a weakest base. Now, your CH3 group, okay, CH3 group. So what type of group it is? What is a methyl group? Electron withdrawing group or electron donating group? Yes. CH3 is what? Methyl group is what? It is a electron donating group, right? So methyl group is an electron donating group. So here, what did we say? Firstly, that ammonia. Okay, among these four, ammonia is the weakest base. Now, your methylamine. So after when you see the your methyl groups. So here, how many methyl groups are there? One methyl group. Here there are two methyl group, and here there are three methyl. So I said that methyl group is a electron donating group. So what will happen? So after, so first will be your ammonia. Okay, first will be your ammonia. Then one methyl group. So what methyl group will do? It will donate the your electrons. Okay, it is an electron donating group. So this the basic strength is little more as compared to your ammonia. Then again one methyl group, right? CH3, NH, and CH3. So again, so there is a increase in a electron donating group. So again, the basic strength has increased. Then again, what? CH3, N, CH3, and CH3. So here again, how many? Three methyl groups are there, right? So what will happen? The basic strength has increased. So why? Methyl is a electron donating group. Okay. So as the number of methyl groups are more, what will happen? The basicity also will be more. Okay. Because the electron density on the nitrogen will be more. Okay. So this is the order. Okay. This is the order. Is it clear? So option number, what is the answer? So let us see. So first will be NH3. Then will be your CH3, NH2, NH3, then so when you see, so this is NH3, okay. So next will be your CH3, okay. But here, what you can see here, one more reason what can be added here, okay. So when we see this, so first will be, as I said, it will be ammonia. First will be your ammonia as it is the weakest base. Then as we say that CH3 is a methyl group. Okay, it is a methyl group, that is a electron donating group. So it will donate the electron, and what will happen? There will be more this. Okay, so because of that we gave this order: CH3, okay, then NH2, then CH3 twice, NH, okay, and then which is greater than CH3 thrice NH. Okay, so this was the order given based upon the electron donating group. Then, but when we see now, when we see this tertiary amine, okay, in case of tertiary amine, you can see that because of the methyl group, okay, there is a what alkyl groups. Because of this alkyl group, there is what more steric hindrance on the nitrogen. Okay, from all the side, the methyl groups are attacking the nitrogen, right? So because of that, the H, the this what bonding by the H plus ions is what it is very difficult, okay, for the nitrogen to bond with the hydrogen. So what will happen? The electrons are so the path is blocked here, right? The path is blocked. So because of that, the basicity is decreased. Why? Because of this bulky methyl group. So because of this, so the basicity, okay, you have to give it as, so first your ammonia, then will be a trimethylamine, okay, trimethylamine. Why? Because of the bulky groups. Then will be your methylamine, okay, then will be a methylamine, and then will be your dimethylamine, okay, then will be your dimethylamine, okay. So what did we say? That methyl groups, okay, methyl group is an electron donating group. As electron donating group, okay, what it will do? It will donate the electron to the nitrogen, okay. So because of that, we have given this order. But from these above, okay, as you see the trimethylamine, okay, because of the bulky methyl group, okay, as there are three methyl groups and the nitrogen is blocked, okay, the path is blocked, and because of that, this is a second weakest, okay. So when we rearrange it, so first will be a ammonia, then will be a trimethylamine, then will be a methylamine, then will be a dimethylamine. So yes, option number A is the answer. So you have to consider the second point also. Okay, you have to consider the second point also. Okay, fine. Next question. So this is a reaction given. So this is a ethyl bromide. Okay, ethyl bromide is there. So ethyl bromide is reacted with aqueous KOH in the, you have to heat it in the presence of aqueous KOH. You will get A. This A, okay, further is reacted with potassium permanganate, okay. In the acidic medium, you're going to heat it, you're going to get B. This B further, you're going to heat it with ammonia to give you C. This is further reacted with bromine in the presence of alkali to give you D. So they have asked what is the D. So follow the set of reactions and tell me the answer. So first is your ethyl bromide, okay, reacted with aqueous KOH. Okay, heat it with aqueous KOH. So what is happening? So Br Okay, Br is a good leaving group. So what will happen? It will be substituted by CH3, CH2, OH. So this is our A. So your Br is replaced by what? OH. Okay, Br is replaced by OH. Now further, second step, KMnO4. Okay, potassium permanganate in the acidic medium. Okay, heated. What you are going to get? Alcohol. So this is a primary alcohol, right? And KMnO4 is what? It is an oxidizing agent. KMnO4 is a oxidizing agent. So what we are going to do? What is happening here? Your alcohol is converted into acid. Okay, your alcohol will be converted into acid. Okay, so there will be removal of hydrogen and addition of oxygen. What you are going to get? You are going to get acetic acid. So this is your option B. Okay, further step is you have to heat it with ammonia. Okay, heat it with ammonia. So after heating your acid with ammonia, you're going to get acetic amide. Okay, you're going to get acetamide. You're going to get what? Acetamide. Amide group you're going to get. Okay. So CH3, C double bond, OH, right? So what I'm going to get? Your OH will be replaced by NH2. Okay, your OH will be replaced by NH2. So I got acetamide. This acetamide further you have to heat it with bromine in the presence of alkali. Okay, bromine in the presence of alkali. So what I'm going to get? I'm going to get a methylamine. Okay, I'm going to get a methylamine. So this is the reaction. Bromine again. Okay, so what I'm going to get? I'm going to get a methylamine. So option number C. Option number C is the answer. So whatever the steps are given on the reaction, okay, that you have to follow. So first, your ethyl bromide is reacted in the presence of aqueous KOH. Okay, heated, you will get what? Alcohol, primary alcohol. Okay, so alcoholic KOH is what? Alcoholic KOH is a dehydrohalogenating agent, right? So alcoholic KOH, I'm going to heat. Okay, so there is a what? Br is replaced by OH. Then further treated with KMnO4 in the acidic medium, heated. What you are going to get? So your primary alcohol will be converted by acetic acid. Okay, this acetic acid, that is, there is a oxidation. Then further reacted with ammonia, heated, you are going to get acetamide. Reacted with bromine in the presence of alkali to give you what? To give you your methylamine. Okay, you are going to get methylamine. So this is the reaction. So our option is option number C. Let us go for the next one. Which one of the following forms propane nitrile as the major product? Which of the following will form propane nitrile as a major product? A. Ethyl bromide plus alcoholic KCN. B. Propyl bromide plus alcoholic KCN. C. Propyl bromide plus alcoholic AgCN. And D. Ethyl bromide plus alcoholic AgCN. Yes. Which of the following forms propane nitrile as a major product? So when you are going to get propane nitrile as a major product? Yes. So propane nitride. Okay. Propane. Propane means how will be a structure? CH3, CH2, and Cn. So this is a propane nitrile. Okay. So if I want to get propane nitrile as the major product, I want to take propane only, right? So what I'll do, I will take propane nitride. Okay. I'm going to take what? I'm going to take ethyl bromide. Okay, I'm going to take ethyl bromide. Ethyl bromide reacted with alcoholic KOH. Okay, reacted with alcoholic KOH. Alcoholic KCN. Let me take KCN. Alcoholic potassium cyanide. Okay, ionic. KCN is ionic. Okay, so there is a ionic bond in between potassium and cyanide. So I'm going to take a potassium that is cyanide. So ethyl bromide. Okay, ethyl bromide reacted with potassium cyanide. Okay, to give you propane nitride plus KBr. So which is our option? Ethyl bromide plus alcoholic KCN. Option number A. Okay, option number A is the answer. So which of the following forms propane nitrile as a major product? So to obtain propane nitrile, you have to take the this also as this only. Okay, so two carbons should be present, right? So then when you are substituting, so when you are reacting with your alcoholic ACN, your Br is substituted by Cn. So one more your what carbon group is introduced. So no issues. So option number A is the answer. Okay. Let us go for the next one. The correct sequence of reaction to para-nitrophenol into quinol involves. So what is the correct sequence of reactions from para-nitrophenol? So what is a para-nitrophenol? So with respect to nitro group, okay, with respect to that is your phenol group, okay, your nitro group is at para position. So this is a para position with respect to your phenol group. So this is a para-nitrophenol. So from para-nitrophenol, I want to get quinol. Okay, what is quinol? Quinol is dihydroxybenzene. Okay, like this dihydroxybenzene like structure. Okay, so this is the quinol. So if I want to convert this from your para-nitrophenol to quinol, okay, how I'm going to get? First, what I'm going to get now? So I have to see this group will be same. Okay, this group will be intact. I have to convert this group now. First step, what I'll do, I will reduce it with, I'll do reduction. I'll do reduction. Okay, with tin and HCl. With tin and HCl, I'll do reduction. So what I'm going to get? I'm going to get what? When you do reduction, okay, I'm going to get our NO2 group will be replaced by NH2. Okay, NO2 group will be replaced by what? NH2. So I'm doing reduction. Okay, nitro group is replaced by NH2. So why? Because I'm doing reduction. Reduction is what? Removal of oxygen, addition of hydrogen. Okay. Now, second step. So again, this will be same. I have to convert this into OH. So what I can do here? I can do diazotization. What do you mean by diazotization? Okay, when you treat sodium nitrate, okay, sodium nitrate in the presence of HCl at 0 to 5 degrees Celsius, okay, I'm going to get what? I'm going to get a diazotized product, okay. So what will be my product now? So here OH and this will be N2Cl. Okay, N2 plus Cl minus. So I have got what? I have got a diazotized product. Okay, now this diazotized product, if I heat it, okay, if I do acid hydrolysis, what will happen if you heat it? After doing acid hydrolysis, I'm going to get a phenol. Okay, so what are the steps? First step is reduction step. First step is reduction step. Second is diazotization. Okay. Second is diazotization. Then third is what? Third is hydrolysis. Okay. Third is hydrolysis. So which is the steps here? Reduction, diazotization, and hydrolysis. Option number A. Option number A. Is it clear? Is it clear? These questions are clear. So we have seen some 5 questions. Is it clear up to here? 5 questions. Yes. Any doubts? Okay. So like this, okay. So let us go for the next questions. The conversion of meta-nitrophenol to resorcinol involves which steps? Okay. So again, one more reaction they have given, meta-nitrophenol. Okay. Now, how do you mean by meto-nitro? Okay. So with respect to phenol, so with respect to, so this is a structure of phenol. Okay. With respect to phenol, this is your nitro group. So this is your meta-nitrophenol. Okay, at meta position, you have what? You have your nitro group and the parent compound is nitrophenol. So from meta-nitrophenol, you have to convert into resorcinol. So what is resorcinol? Resorcinol is OH. Okay. So at meta position. Okay. So this is resorcinol. Resorcinol. Okay. So at meta position, at your OH group is present as what? Meta position. Okay. So what I have to do, this group I have to keep it same. Again at nitro position, I have to do reaction. Okay. So let us see what I can do. First step, again, I can do reduction. Okay, tin plus HCl is a good reducing agent. So when you do reduction with the help of tin and HCl, what I'm going to get? So this is OH and this NO2 group is converted into NH2. What is reduction? Addition of hydrogen, removal of oxygen. So I have done a what? I have done a reduction. Okay, I have done a reduction here. Next step, what I can do? What is the second step? Next step, can I do diazotization again? Yes. Can I do diazotization? Yes, I can do a diazotization. Okay, I can do diazotization. So what is diazotization? So I'm going to get what? Diazotization, what is the reagent? NaNO2 NaNO2 in the presence of HCl, okay, concentrated HCl at 0 to 5 degree Celsius, okay. So that is nitrous acid, NO2. So nitrous acid is generated, okay, with the help of NaNO2 plus concentrated HCl. So diazotization, okay, what I'm going to get? OH again here, this will be N2Cl, N2 plus Cl minus, okay. Now this further, if I do hydrolysis, that is acid hydrolysis, okay, acid hydrolysis, what I'm going to get? Your N2Cl will be replaced by OH, okay. So I am going to get what? I am going to get resorcinol. I am going to get resorcinol. So what are the options? First is reduction. Second is diazotization. Third is hydrolysis. Third is hydrolysis. Okay. So option number reduction, diazotization, hydrolysis. Option number D. Option number D. Is it clear? Is it clear? Okay. Let us go for the next one. Yes. Okay. Next question. Benzylamine is a stronger base than aniline. Benzylamine is a stronger base than aniline. So what is a benzylamine? What is a benzylamine and what is aniline? This is your aniline, right? What is a benzylamine, students? How is the structure of benzylamine? So which is more this? Benzylamine is stronger. Why benzylamine is stronger? Benzene, NH2 attached to a benzene ring. It is aniline. Okay, when NH2 is attached to benzene ring, it is aniline. And what is benzyl? Benzyl group is this. Okay, I'll show you what is benzyl group. This is a benzyl group. Okay, benzene with CH2 is a benzyl group. So benzyl amine. Okay, benzyl amine. Benzyl alcohol. Benzyl alcohol. How do you write benzyl alcohol? CH2OH. Benzyl chloride. Okay, benzyl chloride, Cl. Okay, like this. So like this. Okay, benzyl means benzene with CH2. So what is that? Amine is stronger base than aniline. What is the reason? What is the reason? What is the reason? Here, when you see the placement of nitrogen, amine group. Okay, when you see the placement of amine group, in case of your aniline, okay, you can see the lone pair of electrons on the nitrogen atom in aniline is delocalized. Okay, it is delocalized. Okay, so they will undergo resonance easily because the lone pair of electrons on the nitrogen, okay, the nitrogen attached to directly to the benzene. Okay, so because of that, your benzylamine Here the amine, the lone pair of electrons are directly not involved with the benzene ring, right? So they does not undergo delocalization. Okay, so because of that, your benzylamine is a stronger base as compared to the aniline. So option number B. Option number B is the answer. Okay, fine. Let us go for the next one. Which one of the following gives amine on heating with amide? So we have seen this reaction. There was CH3, C double bond O, NH2, that is acetamide to we got amine, right? So from a amide, okay, we got amine. How? When we reacted bromine in the presence of a alkali. Remember? Remember the step? Which name reaction it is? Which name reaction it is? Where we convert amide into, this is a amide group, into a aniline, that is amine. That is your Hoffman bromamide degradation, right? From your amide, you're converting into amine. So this is a Hoffman bromamide degradation. So if I use bromine in the presence of KOH, okay, aqueous KOH, then I'm going to get amine, right? Option number A. This is a Hoffman degradation. Yes, very good. So option number A it is, okay, not alcoholic. We are going to use aqueous. Okay, so we are going to use bromine in aqueous solution of, you can use either aqueous NaOH or aqueous KOH. Okay, NaOH or KOH. That will give you amine. Okay, and here you can see the number of carbon atoms is lesser. In case of amide, the carbon atoms are 2. Here it is 1. So we had seen this, right? So there it involves. So when we react your amide with bromine in the presence of alkali, you are going to get amines. This is a Hoffman bromamide degradation. Very important. Okay, for your board exam also, this particular reaction is very important. Okay, let us go for the next one. An aromatic compound. Okay, there is an aromatic compound. What is aromatic compound? A C7H9N. Okay, so this on heating with NaNO2 in the presence of HCl at 0 degrees Celsius, it forms benzyl alcohol. What it forms? Benzyl alcohol and nitrogen gas. Okay, nitrogen gas, N2, sorry, N2 gas. Nitrogen gas is N2 gas. Okay. The number of isomers possible for the compound A is. So you have to tell which is the compound A. So this is a reaction. So what they have said, so aromatic compound is there. Okay, that is reacted with, so we are doing what? Diazotization. Okay, we are doing diazotization. That is NaNO2 in the presence of HCl at 0 degrees Celsius. Okay, we are going to get benzyl alcohol. Okay, we are going to get benzyl alcohol plus nitrogen gas. So how many possible isomers are possible for the compound A? Yes. So if I consider, if I seeing the compound, so this is C6, okay, C6H6, this is C6H6. Okay, if I attach one nitrogen, so this becomes C6H, C6H5, okay, then one nitrogen, then H2. So now it becomes what? C6 uh, H, how many? 1, 2, 3, 4, 5, 6, 7. Right, 7. So again, there is a CH2 group left. Right, again, there is CH2 group. So can I do it as benzyl amine? Right, so it becomes CH2 NH2. Now you calculate carbon C7 H 1, 2, 3, 4, 5, 6, 7, 8, 9, yes, and N. Okay, very. So this will be your benzyl amine. Okay, it is benzyl amine. So when you do benzyl with benzyl amine, if you do diazotization, okay, what I'm going to get? I'm going to get a benzyl alcohol, right? So what are the steps? What are the steps? Benzyl. Okay, first step is what? You have taken benzyl alcohol, sorry, benzylamine. Okay, benzylamine. I'm going to do diazotization. Diazotization is NaNO2 in the presence of HCl, okay, 0 to 5 degrees Celsius. So what I'm going to get? I'm going to get CH2 N2Cl, N2 plus Cl minus. Now this further will undergo hydrolysis. Okay, hydrolysis, that is acid hydrolysis. So what I'm going to get? Your N2Cl will be converted into OH. So I'm going to get a benzyl alcohol. Okay, I'm going to get a benzyl alcohol from benzyl amine. From benzyl amine. Now here, what are the possible isomers? What are the possible isomers for benzyl amines? For benzyl amine. Okay. So possible isomers. So let us see. So I can write like this. First is your benzylamine. Okay. Second, I can do as your CH3 and NH2. Okay. So this will be, so it should satisfy this. Okay. This molecular uh, formula. Now, first, so this is first, this is second. Then I can, what I can do, CH3, okay, I can take this NH2 here now, right? Third possibility. Then four possibilities I can take at your CH3 and para position NH2. So this is your fourth. And the fifth I can take NHCH3. Okay. So these are the isomers. So five isomers are possible. Option number A. Option number A. Okay, five isomers are possible. So from option number A, that is your compound, aromatic compound A. So how many isomers are possible is five. Okay, fine. Next question. The correct sequence of reaction to be performed to convert benzene into bromoaniline. So from benzene, this is a benzene. Okay, I'll write it up. So from benzene, I have to convert it into what? I have to convert the benzene into metabromoaniline. Okay, so aniline is like this, and at meta position you have bromo, right? So you are going to convert your aniline. So from benzene to metabromoaniline. So what are the steps? What are the steps? What are the steps? So first take benzene. First take benzene. Okay. So first what I have to do if I want to do your BR group. Okay. First step I have to convert. First I want your aniline group. Right. So can I do nitration? First, can I do nitration? Okay, if I do nitration, I'm going to get NO2. For next step, what I can do? I can do reduction. Okay. After doing reduction, that NO2 will be converted into NH2. Next step, I can do bromination. Okay. Like that, we can try. So first step, let us do concentrate. What is nitration? Nitrating agent concentrated H2SO4 and concentrated HNO3. Okay, so that is nitration by using nitration. So what I am going to get? I am going to get NO2. Okay, so I'm going to get nitrobenzene. I'm going to get what? Nitrobenzene. Now, next step is what? I'm going to do reduction. Okay, I'm going to do reduction. How I'm going to do reduction? Bromine in the presence of water. Okay, bromine in the presence of water. So what I'm going to get here? So second step, let me do bromination. Okay, second step, let me do bromination. First, we will do bromination. Okay, second step, let me do bromination. So first step, nitration, then we are doing bromination. So bromine in the presence of water. So what I'm going to get at meta position, I'm going to get a bromo group. Next step, I'm going to do what? Reduction. I'm going to do reduction in the presence of tin HCl. So your NO2 group, okay, your NO2 group will be converted into NH2 and this will be your Br. So this is metabromoaniline. So three steps: nitration, bromination, and reduction. So option number C, nitration, bromination, and reduction. Okay, option number C. Is it clear? So these are the steps. Okay, like this, you have to remember the reactions. So benzene, when you have to convert it into metabromoaniline, so these are the steps involved. So first, do the nitration, then you are going to do bromination, and then you are going to do reduction. Okay. Next question. So again, a reaction is there. P, okay, there is a P. So this P, okay, you are going to react it with methyl magnesium bromide, okay, for further reacting with. So first step is this, second step is acid hydrolysis. You are going to get R, okay, then this you are reacting with dilute NaOH, okay, and then second step is heat, okay. So the compound, what is P? And you are going to get 4-methyl pent 3 in 2-one. Okay. So P, okay. So when P is there, okay, that you are going to react it with methyl magnesium bromide followed by acid hydrolysis to give you R. Further reacting with dilute NaOH, okay, and heat it. You are going to get 4-methyl pent 2 in 2-one. So what is P there first? What is the P? Starting reactant P. So now how you are going to solve this? Okay. So first step, that is your magnesium, methyl magnesium bromide. So that is what in the presence of it is a Grignard reagent, right? Methyl magnesium bromide. So options are what? Propanone, ethanamine, ethane nitrile, and ethanol. So if I take ethane nitrile as a starting product, okay, CH3C triple bond N. So this is what ethane nitrile. This and further react it with what? Your methyl magnesium bromide. Okay, if I react it with methyl magnesium bromide and acid hydrolysis, I'm going to get acetone. Okay, I'm going to get acetone, CH3C. Okay, I'm going to get CH3C double bond O CH3. Okay, acetone. This acetone, okay, further I'm going to react it with dilute NaOH. Okay, dilute NaOH. So what I'm going to get, it will undergo as when you react your ketone, okay, with dilute NaOH, it will undergo aldol condensation. Okay, I'm going to get a hydroxy ketone. Okay, I'm going to get a hydroxy ketone. So what I'm going to get? So the product will be CH3. Okay, CH3 twice COH, then CH2 CO CH3. CH3 twice COH, okay, double bond CH2 CO CH3. That is 4 hydroxy 4 methyl pentane 2-one. So further it will undergo, if you heat it, I'm going to get dimethyl, okay, that is CH3. That is 4-methyl pent 3 in 2-one. So first step is you are going to react it with Grignard reagent. I'm going to get a ketone. Further react it with a dilute NaOH, undergoes as aldol condensation. Okay, I'm going to get a hydroxy Okay, then what I'm going to get after heating, I'm going to get a this. So our starting, this is ethane nitride. Okay, ethane nitride. One of the following amides will not undergo Hoffman bromamide reaction. So which will not undergo Hoffman bromamide degradation? Who will undergo Hoffman bromamide degradation? Only primary amide. Okay, remember that only primary amides. Okay, only primary, because you are going to get only primary amine. So for Hoffman bromamide degradation reaction, only primary amines are produced. How? By using primary amides. Now, which are the primary amides in the following? Yes, which of the following amide will not undergo Hoffman bromamide degradation? CH3 C double bond O NHCH3. So this is a amide. Okay. Then CH3 C double bond O NH2. So this is also a primary amide. Then C6H5 C double bond O NH2. This is also a primary amide. So CH3CO NHCOH3. Okay. So this is not a primary amide. So first one, A, option number A. So one of the following amides which will not undergo Hoffman bromamide degradation reaction is option number A. So this is primary, this is primary, this is primary. Okay. So this is not a primary. So option number A is the answer. Okay, let us see the 14th one. 13th one we'll see in the next class. Okay. 14th one. What you have here? You have a set of reaction is given. Okay, follow the set of reaction and write it. So 2-bromopropane. So 2-bromopropane. So 1, 2, and 3. So CH3, CH, CH3. So 2-bromo means at 2 position you have a bromo. So this is a 2-bromopropane. So this 2-bromopropane, I'm going to react it with alcoholic AgCN. Okay, alcoholic AgCN, and you're going to heat it. So what will happen? Your bromo group will be AgCN. It is having a covalent bond. Okay. When you have AgCN, what will happen? Which is the reacting side? It will be your cyanide, isocyanide. Okay, it will be your isocyanide. So it will be your isocyanide. So it will be your isocyanide. So what I'm going to get? CH3, CH, CH3 and NC. Okay, and NC. So this is your reacting this. Okay, AgCN. When you are taking AgCN, your reacting this will be nitrogen. So nitrogen will go and attach. So I am going to get what? I am going to get a isocyanide. So this is X. This is your X. Further, I am going to react it with lithium aluminum hydride. So what is lithium aluminum hydride? It is a good reducing agent. So what I'm going to get? I'll add hydrogen. Reducing agent means addition of hydrogen takes place. So CH3, CH, CH3, okay, then NH, okay, NH and CH3. So four hydrogens are added. So what I'm going to get? What is the name of this compound? So N-methyl propane 2 amine. Okay, N-methyl propane 2 amine. So option number C. Option number B. Okay, N-methyl propane 2 amine. Okay, N-methyl propane 2 amine. So option number B. Okay, N-methyl propane 2 amine. 1, 2. Okay, yes. So understood? Okay, so you have to follow the set of reaction what is given and find the answer. I hope it is clear. Okay, so the remaining questions. So we have seen some 13th question. Okay, so this 13th question we will see in the next class. So the remaining questions we shall be discussing in the next class. Okay. I hope the questions are clear. So very easy questions here. So just you need to know the basic. Okay. So what are the steps involved? How we are going to? So what is reduction? What is a reducing agents which can be used? Okay. For nitration, what is the nitrating agent? So these all things you need to require to know. Okay. Rest all things are you can do. Okay. So yes, so remaining questions we shall be discussing in the next class. So I'll end this session here. We'll meet in the next. Thank you.